So the squeeze theorem. Squeeze the theorem. Let g or let f of x be less than or equal to g of x, which is less than or equal to h of x for all x near a but not equal to a if the limit as x approaches a of f of x equals the limit as x approaches a of h of x, then the limit as x approaches a of g of x, if this equals L, then the limit as x approaches a of g of x equals L. And visually what's going on is if I have a graph here, and let's say this is my point A, and I have this upper function here, and I have this lower function here, and it kind of bends down like that, and this upper function bends down like up like that. Then my middle function from both sides gets squeezed into this point. So what are the three things we need to check? One, h of x is greater than or equal to g of x. Two, f of x is less than or equal to g of x. And three, the limit as x approaches a of h of x equals the limit as x approaches a of f of x. Checking these three conditions gives us our result. What's hard? The hard thing is we need to create h of x and f of x. That's really the challenge. To build the upper and lower function, we can take advantage of the absolute value function. Okay, so here, to understand this, I'm going to take the limit as x approaches 0 of x arc tan of 1 over x. Okay. This one is slightly different than what we had before. Okay. Now, with this arc tan of 1 over x, I want to bound it above by something, and I want to bound it below by something. Okay. So x times arc tan of 1 over x is less than or equal to the absolute value of x times arc tan of 1 over x. Okay. Which is less than or equal to the absolute value of x times the absolute value of arc tan of 1 over x. As the range of arc tan of 1 over x equals minus pi by 2 to pi by 2, the absolute value of arc tan of 1 over x is less than or equal to pi by 2. Thus, absolute value of x times the absolute value of arc tan of 1 over x is less than or equal to the absolute value of x times pi by 2. So for the lower bound, the absolute, or x times arctan of 1 over x is greater than or equal to the absolute of x times, or minus the absolute of x times arctan of 1 over x, which equals, and I guess this should be an equality, equals minus the absolute value of x times the absolute value of arctan of 1 over x. As the range of arctan 1 over x is minus pi by 2 to pi by 2, the absolute value of arctan of 1 over x is less than or equal to pi by 2. Thus, the absolute value of x, or minus the absolute value of x times the absolute value of arctan of x, 1 over x, sorry, equals, or is greater than or equal to minus the absolute value of x times pi by 2. Combining these, we get at minus pi by 2 times the absolute value of x is less than or equal to x arc tan 1 over x, which is less than or equal to the absolute, to pi by 2 times the absolute value of x. So the problem. Let's take the limit of minus pi by 2 times the absolute value of x and pi by 2 times the absolute value of x. The limit as x approaches 0, minus pi by 2 absolute value of x equals minus pi by 2 times the absolute value of 0, which equals 0. The limit as x approaches 0 of pi by 2 times the absolute value of x equals pi by 2 times the absolute value of 0, which equals 0. At this point, we have all the pieces to answer our question. We now need our concluding statement. And before I make the concluding statement, I'm just going to do a sidebar to talk about how we use theorems. So, suppose we have a theorem X. So with theorem X, theorem X, and theorem X says, let A be true. Then B is true. So it gives us this set of conditions and it says, let these conditions be true, then this result is true. If I wanted to use this theorem, there's a very specific way we typically use the theorem. Using theorem X. Okay. As A is true by theorem X, B is true. And this is the sentence structure we use. So no matter what our theorem is, we would say as the conditions are met by our theorem, we get our result. And that is how the sentence structure for how we use our theorem. So using this idea, let's go back to our squeeze theorem. So squeeze theorem what is A? A is this piece here. Or more specifically, A is this chunk here. Okay. So I start with as this is true. Okay, and then my B, this is my result for B. So if I go to use this, as minus pi by 2 absolute value of x is less than or equal to x arctan of 1 over x, which is less than or equal to pi by 2 times the absolute value of x for all x near 0. And the limit as x approaches 0 of minus pi by 2 absolute value of x equals the limit as x approaches 0 of pi by 2 times the absolute value of x equals 0. Then, by squeeze theorem, by our theorem, the limit as x approaches 0 of x arc tan of 1 over x equals 0.